Hey class, this is Unit 3 review for 2020. Now I do plan to do most of this review with you in class either Monday or Thursday. So if you plan to be in class, you might want to wait to see these examples done in person. But if you miss class, or if I didn't get to them all, it'd be a great way to review on your own as well. So I'm starting with the oldest stuff and then moving on to the more recent things. And you can jump around if you'd like. So Unit 3 review, we started with complex numbers. So adding complex numbers, all you need to do is combine like terms. So like -2 and 4 is 2, and 6i and 3i is 9i. So adding complex numbers, you just combine like terms, write it as a standard form, so the real part first and then the imaginary part. When you subtract complex numbers, or when you subtract an expression like the 2 minus 8i, you have to remember to subtract both terms in that expression. So how I think of it is like I distribute the negative through. So I gotta get like 30 seconds and charge my pen here. But so I'm gonna have 13 minus 6i, and then minus 2, distribute the negative, and then negative minus -8 will be plus 8i. And then combine like terms. 13 and -2 is 11, and -6i plus 8i is positive 2i. So that's the answer there. So when you subtract with an expression, you need to subtract both terms, which similar to you need to distribute the negative. It's like a -1 in front of the parentheses. All right, multiplying. So the first one I have here can be done two different ways, but you can either distribute the 2 into the first parenthesis and then multiply, or you could multiply these two first and then multiply everything by 2. What you don't want to do is multiply the 2 into both parentheses, because if you have, like 2 times 3 times 4, you just take the first 2 and multiply. 2 times 3 is 6, then 6 times 4 is 24. So the 2 only applies to one of them. So if you multiply the 2 into the first parenthesis, it'd be -6 plus 8i, and then 2 plus 3i. And then you can either distribute this out or use the box to multiply it. So I think more common, I saw the box method, so I'm going to do it that way. If you want to just distribute it, that's fine too. So if you're multiplying 2 by 2, this is how you set it up. You put the first one along the side of the top and the second one along the other side. And then you multiply corresponding spots. So 6 times -2 is -12. -6 times 3i is -18i. 2 times 8i is 16i. And 8i times 3i is 24i squared. And then we have to remember that I squared equals -1. So right here we have 24 times -1, which is really going to be a -24. So then we can combine our like terms. We have a -12 and a -24 that are alike. So adding those together, so once you've multiplied it out, you combine like terms using addition, which would be a -36. And then you have a -18i plus a 16i, and that's going to be -2i. So if you multiply it out and then combine like terms, that's what's left. Put the real part first and then the imaginary part. Okay, if you square something like 2 plus I squared, squaring something means that you need to multiply it by itself. I like to throw this one on the review because many students think they can distribute a square and just square the first and last term, but it doesn't quite work that way. You actually have to multiply it out, because if you just multiply just the first term and just the last term, You're missing the middle terms. So you actually have to multiply it all out. So 2 times 2 is 4. 2 times I is 2I. I times 2 is 2I. And I times I is I squared. Then combine like terms. Remember that I squared is actually -1. So when you have a plus I squared at the end here, you actually have plus a -1. So 4 plus -1 is 3. 2I plus 2I is 4I. And then dividing complex numbers. To divide complex numbers, you need to multiply by the reciprocal of the denominator. And so the reciprocal of the denominator is you just change the imaginary part. So this one is -1 plus 2I, so the complex conjugate would be -1 minus 2I. And then whatever you get for the conjugate at the bottom, you multiply by that as well on the top. And then try to keep your work organized. So multiply out the top. You need to take the 2 minus 3I times -1 minus 2I. So 2 times -1 is -2. -1 times -3I is positive 3I. 2 times -2I is -4I. -2 times -3 is 6. I times I is I squared. Then I squared is equal to -1 here. So this box is actually going to simplify to just -6. 6 times -1. And then combine like terms, -2 and -6 will be -8. And 3I plus -4I will be -1I. So that's what the top will simplify to, -8 minus 1I. Over, then you need to multiply out the bottom. Because they are complex conjugates of each other, the bottom should equal a whole number when you're done. So you have a -1 plus 2I and a -1 minus 2I. And your imaginary parts should cancel. -1 times -1 is +1. -1 times -2I is +2I. -1 times 2I is -2I. And 2 times 2 is -4I squared. And then I squared is -1. So here you have -4 times -1 is going to make that a +4 in the last spot. Then 1 plus 4 is 5. And -2I plus +2I is 0. So there is no imaginary parts. It's -8 minus I over 5 is the final answer for that one. So complex numbers. This is the reason, so the reason we did complex numbers was because when we solve quadratic functions, sometimes we get imaginary solutions. And so that's why we spent some time learning about complex numbers. So the next section we started was solving by square roots. So to solve by square roots, you need to isolate the part that is being squared, and then square root each side and finish solving. So in this case, the part that's being squared is this parenthesis. And so we want to get that parenthesis by itself. So the first thing I'll do is add 21 on both sides. And I'll get 7, and then x minus 2 squared is 21. So I can't distribute the 7 into the parentheses because it's being squared, and I don't want to multiply it out either. I want to leave it as the parentheses squared. So then divide by 7, and I get x minus 2 squared equals 3. Now to get rid of the square, take the square root of both sides. So then we get x minus 2 equals, plus or minus, anytime you are solving and you take the square root, you get two answers, a positive and a negative. And then the square root of 3 doesn't simplify, so the square root of 3. Last step would be to add 2. We get x equals 2 plus or minus the square root of 3. Okay, so this one is kind of similar. We want to get this x plus 5 squared by itself. The first thing you need to do is get rid of the fraction. Dividing by a fraction, since it's 1/2 times that, is the same thing as multiplying by its reciprocal. So if you have a fraction, multiply by the reciprocal. The reciprocal would be -2/1, which is -2. So multiply by -2 on both sides, because that's going to give me -2 over -2, which is 1. So on this side, I'm just left with x plus 5 squared. 2 times -2 is -4. Then take the square root, and we get x plus 5 equals, the square root of 4 is plus or minus 2. Since it's a -4, it is imaginary 2, so plus or minus 2i, because the square root of 4 is 2 and the square root of -1 is I. Then subtract 5 from both sides. You have a real number and a complex number, so now your answer is imaginary. So put the real part first, -5 plus or minus 2i. That's -5 plus 2i and -5 minus 2i. Remember, if that would have been -5 plus or minus 2, then you can give me two answers for that because they're both real numbers. -5 plus 2 is -3, and -5 minus 2 is -7. So in that case, you should take it a step further. If it's just an imaginary, or if it's real and imaginary, you have to leave it as complex. The last one, if you add 9 to both sides, and then you divide by 4 to get the x squared by itself. Except for that 9/4 gives me a decimal, so I'm going to leave it as a fraction, 9/4. Then when you take the square root, you square root a fraction, you take the square root of the top and the bottom separately, and you're going to get x equals, you still get two answers, so plus or minus, the square root of 9 is 3, and the square root of 4 is 2. So 3/2 and -3/2 for the answer there. All right, then we did solve by completing the square. Completing the square has multiple steps, so it does take some practice so that you remember all of the steps. First step is that a has to be equal to 1, which it is. The next step is that you need to move the c value to the other side of the equation, so subtract 3 from both sides. So I'm going to get x squared plus 12x plus blank equals -3 plus blank. I add my plus blanks in there. You don't have to do that, but I like to because that reminds me that that's where I need to complete the square. So you take half of the middle term, which in this case is 12, divide it by 2, and you square it. 12 divided by 2 is 6. 6 squared is 36. You must add that to both sides of the equation to make sure that it stays balanced. Then you factor the left side. So it multiplies the 36 and adds up to 12. That's +6 and +6. So it multiplies or factors to x plus 6 squared. Whatever you got when you divided the middle term is what goes in those parentheses, if you remember that pattern. Then -3 plus 36 is +33. Then take the square root of both sides, so you get x plus 6 equals plus or minus the square root of 33. 33 is 3 times 11, so it doesn't break down any further, but if it did, I would want to break that down. It's irrational then, so I'm going to leave it like that and subtract 6, and you'd write your answer. The whole number goes first, and then square root of 33. So it's -6 plus the square root of 33 and -6 minus the square root of 33. We leave our answer like this so that it's exact and not a decimal, because it's irrational. The decimal would go on forever. So we just leave it like this, in exact form. Do one more, completing the square. This one's a little bit more challenging. It always seems to throw students off. So a has to be equal to 1. So before I can start, I have to divide everything here by -4. That gives me x squared minus 1x minus 2 divided by 4 is a half, and 0 divided by 4 is 0. Then I have to move the c value to the other side, so I have to add a half to each side. So I'm going to get x squared minus 1x. I am going to add my plus blanks, 1/2 plus blank. Then you take the middle term, which is -1, divide it by 2, and square it. When you square a fraction, you square the top and the bottom, or you think of it as -1/2 times -1/2, which would be +1/4. When you factor it, it's going to be x minus a half squared, because 1/2 times 1/2 is 1/4, and -1/2 plus -1/2 is -1 in the middle. So that's why it factors that way. Also, whatever this value is what goes in those parentheses. To add fractions, you have to have a common denominator. So between 2 and 4, I'd use a denominator of 4. So change a half by multiplying it by 2 on both the top and bottom, so that it is 2/4. Then 2/4 plus 1/4 is 3/4. Then we square root each side. When you square root a fraction, you square root the top and the bottom separately. So you get x minus 1/2 equals positive or negative. The square root of 3 is irrational, so the square root of 3 over 2. Then you add a half to each side, and you get x equals 1/2 plus or minus the square root of 3 over 2. I would just leave it like this, since your answer would be irrational. Since they do have common denominators, you could write it as 1 plus or minus the square root of 3 all over 2. That would be another way to write that. But either way, it's going to be a decimal if you were to actually use the calculator to figure it out. So leave it like that. Okay, after completing the square, we talked about factoring. We did do some special patterns. So we had the perfect square trinomial. So like the ends were perfect squares. 9 was 3 times 3. 25 was 5 times 5. Well, if you think about that, 3 and 5 are 15, and 3 and 5 make 15, and 2 15s make 30. So it is a perfect square. So it would factor to 3x plus 5 times 3x plus 5, or 3x plus 5 squared. So if you see the perfect squares on the ends, I would try that pattern first to see if it works. If it is positive here, it is positive here. If it is negative there, then it is negative in the answer as well. This one is difference of perfect squares, a squared minus b squared. 121 is 11 times 11. And 16 is 4 times 4, and then it adds up to 0 in the middle, so 1 is positive and 1 is negative. This one, oh, actually, this one doesn't factor. If it would be a minus here instead, then it would be difference of perfect squares. It'd be x times x, and then 25y squared would be 5y and 5y, and then 1 positive and 1 negative to make it add up to 0 in the middle. We spent a lot of time factoring, and then we used factoring to help us solve. So we solved this same problem using square roots in the earlier example. If I wanted to solve by factoring, I would factor it so it's difference of perfect squares. So 4x squared is 2x times 2x. 9 is 3 times 3. It adds up to 0, so 1 is positive and 1 is negative. Then to solve by factoring, you set each factor equal to 0, and then you solve each one. So 2x plus 3, you'd subtract 3, and then you would divide by 2, negative 3/2. Now, if you were to do the similar steps over here, the only thing that would change is that you would add 3, so you'd get positive 3/2. When we solved it with square roots, we got plus and minus 3/2, so same answer. So this one also has two terms, but it is not difference of perfect squares. There's no minus here. And notice that the second term has an x. And so this one, if you see something like this, look for the greatest common factor, which in this case, I can take out a 4 and an x. That leaves me with a x plus 4. Then set each factor equal to 0. And we get x equals 0 or x equals negative 4. To continue solving by factoring, remember it does have to be equal to 0. And then this one, it looks like I can take out a 3. And that would leave me with a 2x squared minus 11x plus 5. Technically, since the 3 doesn't have an x, it's not going to have an answer. So you could divide both sides by 3 and then just get rid of the 3 right away, because it doesn't have an x, so dividing both sides by 3. If this was just a factoring question, the 3 would have to be out in the final answer, because 3 is the reverse of multiplying it. And so to get back to the original answer, you do need the 3. But when solving, since there's an equal sign, you can get rid of the 3 by dividing both sides by 3. Then this one, either it's guess and check now or use the box. So we got 2x squared and positive 5. And 2 times 5 is 10, but it needs to add up to negative 11. So if it's positive but adds up to a negative, both your factors have to be negative. And then using 10 to make 11 would be 10 and 1. So negative 10x and negative 1x. Now if I look at these two, 2x and 10x, they're both divisible by 2x, so I'm going to put that here. Then 2x times 1x is 2x squared. 2x times negative 5 is negative 10x. And 1x times negative 1 is negative 1. So it factors to 2x minus 1 times 1x minus 5, or just x minus 5. So if I was factoring it, I would need the 3 out front for my final answer. If you're solving it, then you just need to set each of those factors equal to 0, and you don't need the 3 because the 3 didn't have an x. So here I'd add 1 and then divide by 2, which would give me x equals 1/2. And this one I would add 5 and get x equals 5. So I had two answers there, 1/2 and 5. It does have to be equal to 0. So if you want to solve this one, you have to start by moving everything to the other side. So you have to subtract an x squared, add an x, and subtract a 4. And this one might look familiar because I think it was actually in your problems on your student warm-up, but I saw a lot of mistakes, so I threw it on here. First, 4x squared minus x squared is 3x squared. 10x plus an x is an 11x, and then minus 4. So then factoring it, 3x squared negative 4 gives me negative 12. That adds up to 11. It's negative 1 and positive 12. 3x squared and 12x are both divisible by 3, so 3x goes there, times x times negative 1, 3x times 4. So solving, 3x minus 1 equals 0, or x plus 4 equals 0. This one you would add 1, 3x equals 1, divide by 3, x equals 1/3. Here subtract 4, x equals negative 4, should be the two answers for that one. The quadratic formula. So the quadratic formula is x equals negative b plus and minus square root b squared minus 4ac all over 2a. And the b squared minus 4ac part is the discriminant, and that tells us how many solutions we have. So if a, b, and c, b is 1, c is 1, a is 2. So it'd be 1 squared minus 4 times 2 times 1. So that's 1 minus 8 is negative 7. So Since it's a negative under the square root, means it's going to have two imaginary solutions. This parabola has an a value of positive, so it's going to open up. If it has imaginary solutions, that means it never crosses the x-axis. There are no x-intercepts, no real solutions. Finish solving it would be x equals negative b would be -1 plus or minus the square root of -7 over 2a, so 2 times 2. So I would just finish this by -7 is going to be the I square roots of 7, and then over 4. And those would be my answers, or my zeros, or my roots, my solutions. Oh, what did we do next? Then we graphed from vertex form. So the vertex comes from the first and the last term, so -3, -5. The axis of symmetry is the x-coordinate of the vertex, so the vertex is at -3, -5. I use the parent function, so x, y, a, y table, 1, 2, 0, 1, 2, 3, 0, 1, 4, and 9. And then our a value in this one was a -1/2, so it's going to be wider, and it's going to open down instead of up. So timesing the middle column by 1/2. So 1 times 1/2 is -0.5, 2 times 1/2 is -2, 9 times 1/2 is -4.5. Then my 0, 0 is my -3, -5 point. So that's where I'm going to be graphing these from. My axis of symmetry here is this line. That's where I got x equals -3. 0, 0 is that vertex point. Then 1 over 1 down 0.5. So from the vertex, over 1 down 0.5. Then over 2 down 2. From the vertex, over 2 down 2, reflected over. Then over 3 down 4.5, reflected over. So equidistance on the left side to the right side to reflect it. I would say that this one is wider than the parent function. It opens in the opposite direction, and it was shifted to the left 3 and down 5 if I was asked to describe the transformations. This one, the axis of symmetry would be at -5 because the vertex is -5 and 2 from my graph. My a value is -3. That means it's going to be a vertical stretch. It's going to be much more narrow than the parent function, and it's negative, so it's going to open down. I'm going to have x, y, a, y. So 0, 1, 2, 3, 0, 1, 4, 9. And then a is -3, so 0, -3, -12, -27. The last one's not going to fit on the graph, and that's going to be okay. Graphing the vertex, -5, 2, that's going to be my 0, 0 point. Then graphing the other one, so over 1 down 3 from that vertex point, over 1 down 3. And then reflect it over the axis of symmetry, which was at x equals -5. And then over 2 down 12, which is the very bottom, and then reflect it over. And then trying to draw that parabola so it is more rounded. This vertex is a maximum value, and it's the y value, which is at 2. It's maximum because it opens down. It'd be a minimum if it opened up, and it's always the y coordinate of the vertex that corresponds to. It's asking me for the solutions. That'd be the x-intercepts. I'm not going to solve this one. If you wanted the solutions, you would have to set it equal to 0 since it doesn't cross at an exact value, and you'd have to solve it. And we're not going to do that right now. I guess I could left that. What else is it going to ask you? Oh, the transformations. So it was shifted to the left 5 and up 2. The a is 3, so it was a vertical stretch, which means it is more narrow, and it opens in the opposite direction as the parent function, or it opens down. Last thing we did was writing equations using those transformations. So write an equation that is opening the opposite direction, It's narrower and it's translated 3 units left and up 5. So first find the current vertex, which is at 4, -2. And then my A value is at 1. So if I wanted to open in the opposite direction, I need it to be negative, and then narrower, I need it to be bigger than 1. So maybe in my new function, I want to have -2 as my vertex, or as my A value, because that will make it open the opposite direction, and the bigger it is, the more narrow it is. So it's bigger than 1, so it'd be more narrow. Translated left 3 units means I'm going to take the x coordinate and subtract 3. Up 5 means I'm going to take the y coordinate and move it up 5, which would be, the new vertex would be 1, 3. So it'd be x minus 1 squared and then plus 3. And the last one for review, this is very long, so this video is very long. Write an equation for the quadratic function, opens opposite direction again and is wider, so the current value A is -2, so I need it to be opposite, so I need one that is positive, and then wider means that it needs to be less than 2. So maybe I want it to be +1 or +1/2 would be wider. Then translated left 3 and down 5, I would take the current vertex, which is +2, 3, opposite of the first one. Left 3 would be -3, right 3 would be +3, and then down 5 is -5. So 2 minus 3 is -1, 3 minus 5 is -2. That'd be your new vertex. That's what you plug in for HK. So it'd be x plus 1 squared and then -2 would be the equation. I hope this was helpful.